Hello everyone, welcome back to C Advanced. Yesterday we covered pointers and double pointers. Today we are going to dive into the dynamic memory allocation. Dynamic memory allocation allows us to allocate memory at runtime, which is especially useful for handling data structures like arrays or linked list when the size is unknown at compile time. In this video we'll explore how to use functions like malloc, calloc and realloc and also free function to manage memory dynamically. Let's get started. Dynamic memory allocation is the process of allocating memory during the program's runtime rather than at the compile time. This gives flexibility to allocate exactly the amount of memory needed and free it once done. So when we initialize a variable with a static declaration, it is usually assigned at the time of compile time. The memory is assigned at the time of compile time. Rather if we do it as a dynamic memory allocation, the memory will be allocated during the runtime. In C, we have a set of standard library functions that helps us allocate and manage memory dynamically. These functions are malloc, which stands for memory allocation. It just allocates the memory. Calloc, it stands for contiguous allocation. It allocates and initializes the memory to 0. Realloc, which stands for resizing and the memory. And last we have free function that deallocates all the memory. Let's start with malloc function. This function is used to allocate a block of memory. The syntax is as given here. The data type star malloc size underscore t size bracket close semicolon. Here size underscore t is a type used to represent the size of memory block you want to allocate in bytes. Malloc function returns a pointer to the allocated memory block. If the memory allocation fails, it returns null. Let's take a look at an example. Here, we'll dynamically allocate memory for an array of integers. We can see that here we are having a pointer called *arr with integer type. We allocate the size n. N is a variable with the size. For example, we can declare n as 5, say. Now we are, if n is 5, we are assigning to this variable pointer *arr with a variable with an array of size 5. This is an example to illustrate malloc function. Here, as I said, we have declared the pointer arr. We have assigned the value 5 to a variable called n. Then we assigned arr with a dynamically allocated memory space of 5 integer variables. So here the size of integer is usually 4 bytes. So we'll be allocating 5 into 4, which is 20 bytes for this particular memory uh, pointed by this pointer *arr. So here in this if condition, we are checking if the array is returning null in any of the memory space, then we'll have a memory allocation failed dialog failed warning displayed. Now after that, we are printing the value in the memory location. We are assigning that particular memory into I into 2. I is 0 to 5 here. So it will be 0, 2, 4, 6 and 8. As you can see here, it is displayed here as output. After everything, we are freeing the memory space that we allocated dynamically in the memory space called pointer called ARR. Now let's talk about contiguous allocation, calloc function. This function is similar to malloc, but with an important difference. Calloc not only allocates memory, but also initializes it to 0. It allocates contiguous memory space. So the syntax is as given here. The data type star calloc size underscore t num size underscore t size. Here you can see the syntax is a little different because we have two arguments here. In the malloc function, we only had one argument, and that was the total number of space. So we multiplied both these parameters. Now uh, num is the number of elements to allocate, and the size is the size of each element. Okay. Let's see an example of where we allocate memory for an array of integers and initializes them to 0. So here this is example. In ARR we are assigning it by using calloc function. Here n is the number of elements, and this parameter is the size of the each parameter, each element. This is an example to illustrate the contiguous allocation function. Here we declared, as usual, we declared a variable that specifies the number of elements to dynamically declare. Here we allocate and initializes the memory to 0. If any of the memory is null, because if the memory allocation failed, the memory will be allocated with null. So we are checking if it is null. If it is null, it should be displayed as output. So our execution was successful. So memory was allocated successfully. Now after that we are printing the value of the each memory space from 1 to 5. Here we just printed what is there in the memory. We didn't assign anything. So calloc assigns the value of each memory space to 0 by use. When we use this function, it automatically assigns the value to be 0, as you can see in the output. Next we have realloc function. This function is used to resize a previously allocated memory block. The syntax is the data type star realloc void star pointer, then size of the memory. Here ptr is a pointer to the previously allocated memory block. Size is a new size of the memory block. Here this realloc function is used to reallocate the memory space of a previously allocated pointer. Okay, so, for example, we have allocated 10 memory spaces previously, and we now know that we need 20 memory space. We need a 20 block array. Then we can reallocate that same pointer memory space. Okay, that is why we use realloc function. Now let's see how we can use realloc to resize any array through this function. So this is an example to illustrate the realloc function. Here we have assigned a variable, a static variable n with 5. We just want 5 elements to be assigned uh, dynamically allocated memory. We need 5 dynamically allocated memory space, int memory space. So we are allocating malloc 5 into the size of integer. We are allocating it to the pointer ARR. After that, if any of the memory allocation failed, we are printing a warning. Uh, Memory allocation is failing. Then after that, we are assigning each of these 5 elements with values as I into 2. Here I goes from 0 to 4. So the first memory space will have value 0, second space will have value 2, third will have values 4, and so on until 8. After that, we are reallocating it. So we reassign the value of n to 10, and we are reallocating the values in the pointer ARR. So in star realloc ARR comma, we have two parameters here. Sorry, arguments here. ARR and n into size of integer. That is the number of elements into the size of the data type. If if the reallocation failed, or that is if 10 elements are not uh, allocated by the system, then we will be having we'll be printing a warning message saying that the memory allocation is failing. After that, we are putting another loop to print the value of each element. So from I is 1 to 10, uh, I is from 0 to 9, sorry, and it will print the value of the memory space. Finally, we are freeing out the pointer ARR. Memory is dynamically allocated through the pointer ARR. So the output displayed here is 0, 2, 4, 6, and 8. So this first five elements were the ones that we assigned using this loop, and after that it is assigning 5 more memory space with garbage value. It has assigned 0, then 1, 1, 3, 4, 4, 8, 1, 1, some garbage value. Then it has assigned 3 more zeros. So uh, it has assigned 10 dynamic memory spaces, and without changing our previous assigning. We have assigned the previous 5 memory spaces to 5 values. It has not thrown out those values, but it has assigned 5 more uh, memory space. So this is just an example to illustrate realloc function. Lastly, we have the free function. This is a function that is used to deallocate memory that was previously allocated using malloc, calloc, or realloc functions. So we have used free function in all of our examples that I used for illustration. The syntax is void free the pointer, whichever pointer that we want to deallocate the memory. Now it is essential to free dynamically allocated memory to avoid memory leaks. Here is how we used free function in the previous examples. It is just like we can use it like free inside bracket the pointer. To wrap things up, dynamic memory allocation is an important concept in C programming. It allows us to allocate memory at runtime, providing flexibility when working with data of varying sizes. Today we covered following functions: malloc, calloc, realloc, and free function. So in the next video, we'll be exploring more advanced memory management techniques. Always remember to always free dynamically allocated memory to avoid memory leaks. In the next video, we'll dive into the more advanced concepts. Thanks for watching. Like, share, and subscribe if you like this video. And I'll see you in the next one. Thank you.